In the previous video, we introduced the derivative, a new function that told you the slope of the graph at any x value. In this video, we will continue practicing how to find the derivative of a function. Example 3. Find the derivative of f of x equals the square root of x, then use it to find the slope at the points 1, 1 and 4, 2. What's happening at 0, 0? So here's that definition of derivative for reference. You should probably memorize this. F prime of x equals the limit as delta x approaches 0 of, we have f at x plus delta x. The function is the square root of x, so this means we're going to take the square root of x and substitute in x plus delta x. So here is x plus delta x. That is this part now done. Now we're going to subtract f of x. So minus, well, guess what? This is f of x right here. It's just the square root of x. So now we've done this part. And then that's over delta x. So how can we simplify this? When you see radicals, and especially when you see a sum or a difference, the first thing you should be thinking is maybe the conjugate. What happens if we multiply by the conjugate? So the conjugate is where if I have a plus b, the conjugate would be a minus b. So I'm looking at the numerator right here, and I'm going to multiply by the conjugate. So I'm going to start off with the square root of x plus delta x, but this time I'm going to do plus the square root of x. That's the conjugate. When you do this, you need to do it in the numerator and the denominator, the exact same thing. That way you're really just multiplying by 1. So I'm going to put x plus delta x plus radical x down here. All right, I'm going to need this space. So I am foiling this out. All right, a binomial times a binomial. I'm about to FOIL right now, but it's a little bit of a shortcut. So I'm going to do f prime of x is equal to the limit as, well, I forgot the x, didn't I? As delta x approaches 0. And so here I'm going to start foiling things. The beauty of the conjugate is the inner part always cancels itself out. So for example, if I do a plus b and then I do a minus b, when I do the distributive property twice, I'm going to get x squared, and I'm going to get plus ab, and then I'm going to get minus ab, and then it'll be minus b squared. But this always happens. Plus ab minus ab, the middle cancels out, and you just wind up with a squared minus b squared. So I'm going to use that fact to my advantage. And so it's just going to be the first radical. Here, let me circle some things. Focus on this. I'm multiplying this times this right now. If you multiply a radical times itself, the radical goes away. So as I multiply those two together, I'm just going to get x plus delta x. All right, as you saw, the middle terms will all cancel each other out. And then I'm going to be down to this times this. It's a negative times a positive, so the result will be a negative. But again, when I do a radical times itself, the radical goes away. So that's why I'm going to have negative, because negative times a positive is a negative, but the radical goes away and I just have x. Now I'm looking at the denominator. I am multiplying delta x times this denominator. In fact, I'm just going to leave it like that. So I'm just going to put delta x, and then in parentheses, I'm going to put this. the square root of x plus delta x plus radical x. Bam! This is the derivative. Let's keep simplifying. Notice that these terms cancel. I see x and then I see negative x. Those are going to cancel each other out. Recopy. So I have f prime of x is equal to the limit of delta x, well, the limit as delta x approaches 0. And then in the numerator, I just have delta x, and then in the denominator, unchanged. For x plus, whoops. All right, plus radical x. Okay, notice that we have delta x in the numerator and the denominator. So these are going to cancel out. I'm going to need a 1 in the numerator as a placeholder. So then I have f prime of x is equal to the limit as delta x approaches 0 of 1 over the square root of x plus delta x plus radical x. We finally gotten to a point where we can do direct substitution. Up until now, if I substituted 0 in for delta x, I was going to have a 0 denominator, undefined. But now it's okay because I just have this one little delta x right here. If I substitute in the 0, this goes away, but I have other stuff. All right, it's not going to be a 0 denominator. Be careful. As soon as you do the substitution, you've already taken the limit. So notice I am not going to write the limit as delta x approaches 0. I'm not going to write that anymore. So I'm just going to have f prime of x is equal to 1 over radical x plus radical x. But of course, a better way of writing that would be 1 over 2 radical x. So that is the answer to the first part of what we were supposed to find. This is the derivative of f of x. Do not forget what this means. This is a formula for the slope of a curve at a point. This is the slope of f of x at any x. All right, that's what we found. So we're going to use this formula to answer the other questions. All right, we want to know what's the slope at 1, 1 and 4, 2, and what's up with 0, 0. So let's go ahead and find the slope at 1, 1. All that really matters here is the x value, which is 1. And here we have a formula for the slope. So if I want to find the slope at an x value of 1, I'm going to do f prime at 1. So that would just be 1 over 2 times the square root of 1. I'm just substituting 1 into the formula. That's going to give me the slope. All right, so the slope at an x value of 1 is 1/2. All right, what about the slope at the point 4, 2? Again, all that really matters is the x value. So the slope is going to be f prime at 4. So substituting 4 in for x, that would be 1 over 2 times the square root of 4. All right, so the slope at 4 is going to be 1 over, well, this is 2 times 2, obviously. The square root of 4 is 2. So that's just going to be 4. All right, so the slope of the original function, well, the slope of the square root of x at the point 4, 2 is 1/4. So last but not least, what is going on at 0, 0? Okay, let me see if I can squeeze this in right here. What about 0, 0? Question mark. Well, if I try to do the same thing I've been doing, I might do this. I might say, okay, what's the slope at 0? Okay, looking at this part. And I might think, well, 1 over 2 times radical, this is going to give me a 0 denominator. What is the deal? Okay, this is undefined. That's no good. All right, this is because there is the slope is infinite. All right, in other words, the tangent line is a vertical line. Okay, so there is no slope at 0, 0 because the tangent line is vertical. This video is getting a little bit long, but I want to squeeze in one more example. In this example, I'm going to use a different variable t. By the way, if you're like me, you don't like it when they use t for a variable because it sort of looks like a plus sign and you can make a mistake, especially if your handwriting is not great, which mine isn't. However, in calculus, a lot of times we're going to use t to stand for time. It just comes up a bunch. We have no control over it. We don't write the textbooks or the AP tests. So get used to it. So let's find the derivative of y equals 2 over t with respect to t. So since we're using y, we will use the notation y prime to represent the derivative. And keep an eye on the definition of derivative. Please memorize this. And this will be the limit as delta x approaches 0 of, you know what, I need more space. I need room because there's a fraction here. So I'm about to do this part right now. F at x plus delta x. Here's the function, 2 over t. So I need to take the function 2 over t, but in place of t, I need to substitute x plus delta x. Well, actually, I'm messing up already. We should be using t's instead of x's. So I should be doing t plus delta t. And when I said delta x down here, I should have said delta t. Okay, just a different variable. Everything else is the same. Anyway, now we're going to do this part where we're doing minus f of x, but it will be minus 2 over t. All right, it's just minus the original function. And in the denominator, of course, we will have delta t. Okay, so there's the definition of derivative. Now it's just a matter of simplifying this. So first of all, let's separate this out. You guys understand, if I have a plus b over c, I can write this as a over c plus b over c, right? I can divide each separately and make two separate fractions. So that's what I'm about to do right now. So this is going to become y prime is equal to the limit as delta t approaches 0 of, and I have 2 over t plus delta t, and that's going to be all over delta t. All right, I'm just splitting it up. And then on the other side, I will have 2 over t all over delta t. Here's another little shortcut you should know and memorize. Let's say I have a fraction and I want to divide it by an extra number. The bottom line is the extra number I'm dividing by is just going to join into the denominator. So the result is going to be a over b, all right? That's just my original fraction from the numerator. But then the c will just show up in the denominator. Technically, what I did was I multiplied by the reciprocal. If this was c over 1, then this business would become a over b times, all right? And I'm multiplying by the reciprocal. It'd be 1 over c. So you can see how I'm going to get a over bc. I don't want to go through this thought process every time. If you have a fraction divided by a third thing, just stick it in the denominator. It's quick, it's easy. Do it. All right, and that is what I'm about to do right now. Twice. I have a fraction divided by an extra thing. All right, so this extra little guy is just going to end up in the denominator next to what's already there. All right, same thing here. This is just going to end up in the denominator next to the t. Okay, there you can see I did exactly what I said I was going to do. I left it here in blue so you could follow where the little delta t's went when I moved them up into those denominators. Now, our strategy will be to try to combine these into one big giant fraction. But to combine them, I need like denominators. We've done part of the job already because both denominators have a delta t, so that's great. Now, I'm noticing that the denominator on the right has a t, just a plain old t. The denominator on the left does not have that, so I'm going to give this denominator a t, but it only works if I do it in the numerator and denominator. That way I'm multiplying by 1. I'm not really changing anything. So now everybody has a delta t, everybody has a regular t. So the only thing missing is the first denominator has parentheses 2 plus delta t. The second denominator does not have that, so I'm going to give it one. Did I say 2? T plus delta t. So here's a t plus delta t. And again, that's only okay if I do it in the numerator as well. So t plus delta t in the numerator 2. Now all of the denominators are the same. So I can combine these into one big fraction, keeping the common denominator. Normally I would skip this step and go straight to the next step, but there's a common mistake here that I wanted to emphasize. It has to do with the minus sign right here. I'm going to have to do the distributive property with this 2. And a common mistake is to simply multiply through by 2. But really, this is going to act as a negative 2. It's sort of like, imagine this is a plus and the minus went up here. I have to distribute a negative 2. And a lot of students don't do that, and they wind up with a positive where there should be a negative. So I went ahead and showed this extra step because now it'll be that much more clear that I'm distributing a negative 2 right now. So now I have all of this. Scan through the numerator. Do you see anything that can cancel out? Of course, you see the 2t and the minus 2t. And that's the key. We really went through all of this so that we could cancel these out. Well, so that we can cancel out the delta t's on the next step. So now we have this. Notice that we have a delta t in the numerator and the denominator, so we can cancel those out. And now we are almost at the end, because now that we canceled out that extra factor of delta t, we are in a situation where we can do direct substitution. To calculate this limit, we can just put in 0 for delta t. So if we put in 0 right here, then the delta t goes away, but the t and the other t will still be there. So that's going to leave us with y prime is equal to the limit. Actually, no, I almost made the common mistake. Once we do that substitution, we've already done the limit, so we're not going to write limit again. The limit is -2 over, and we're just going to have t times t. Maybe I'll just go ahead and show one more step. All right, the delta t is gone, but I still have the t times the t. So of course that means that y prime is -2 over t squared. And this is the derivative of the original function. Every time you do a derivative, I want you to stop and think about what you just found. The derivative means the slope of a curve at a point. So this little formula that we just came up with tells you the slope of the curve, and in this case the curve was y equals 2 over t. But this formula tells you the slope of this curve at any x value. Well, I mean t value.